Okay, good day. We'll discuss logarithmic equations and inequalities. But in this video, we'll only discuss the logarithmic equations. And by the way, this is an a part 2 of the logarithmic equations examples. So these are just as the additional examples. So the part 1 for logarithmic equations, the link is posted on the description box. So we have these following problems. So for equations. So solutions for number 1, given log of x base 3 equals 2. So of course, we will not use calculators in the calculator in this video. So the first step is of course to convert this one into its exponential form. Remember that if we have log of a base b equals c, this is equivalent in exponential form, the b raised to c equals a. So that is the direction. B raised to c equals a. So we'll start at the base, raise it with the c, and then equals the a. So in this case, it will be 3 raised to 2 equals x. Okay, so 3 raised to 2 equals x. And then 3 squared is 9. So therefore, x is equal to 9. Number 2, we have this. So the same thing will happen. Let's start with a base. 4 raised to negative 3 over 2 equals y. Okay, so 4 raised to negative 3 over 2 equals y. And then take note, we can do this. Factor out the 1/2. 4 raised to negative 3 is 1 over 4, 3, if we take the reciprocal. And then 4 cubed is 64. Now 1/2, it means the square root. Take note that in general, if we have the nth root of a, this is equivalent to a raised to 1 over n. If it is like this, it is understood by convention that the index here is 2. So a raised to 1 over 2. Okay, so it means the square root of 1 over 64. So it's 1 over 8. So y is equal to 1 over 8. Number 3, so we have this. So x squared x raised to 2 equals 25. So we have x squared is equal to 25. So this is 25. So if this is 25, we'll just take the square root. The square root of 25 is plus and minus 5. Take note, we'll just take the square root. So that is plus and minus 5. But of course, we'll just take positive 5 because x is a base. And by definition of logarithm, a base must be positive. So the minus 5 is not acceptable. So our final answer is just positive 5. Number 4. So again, let's have this, the same solution with the previous one. Y raised to negative 2 over 3 equals 9 over 4. So I have this. Now take note, 9 over 4 is equivalent to 3 over 2. And then we have a square outside the parenthesis. Because 9 is 3 squared. And 4 is 2 squared. And by property of exponents, this is equivalent to this. Okay? And then take note, we only need y. So we can multiply negative 2/3 by negative 3/2. Because negative 2/3 times 3/2 or negative 3/2, this is positive. Then we can cancel 3, cancel 2. So we have 1. So 1 times 1 is 1. So that's why we have y raised to 1. Now, to maintain the equality, of course, if you raise this side by negative 3 halves, you also raise the other side by negative 3 halves. Now in this case, we can cancel 2 because this is equal to 2 times negative 3 halves. So we can cancel 2. That is why we're left with negative 3. If we take the reciprocal, it will become 2/3 and then positive 3. And by the laws of exponent, we have 2 cubed over 3 cubed. So we have 8 over 27. So it is positive, therefore we can accept y is equal to 8 over 27. Take note, y is our base, so it must be positive. Number 5, we have this. Now, take note that there is no base here. If there is no base indicated, it means that the base is 10. Okay, the base is 10. So we can rewrite this one as the 10 raised to 0 equals 3x squared plus 2x minus 4. So the same thing, the base raised to 0 equals 3x minus 4. Now 10 raised to 0 is 1. And then transpose to the other side, we have this, negative 1. It will become negative 5. And then if we factor this is equal to 3x plus 5 times x minus 1. Okay, and then we have two values of x. We have 3x equals negative 5, of course, and then divide both sides by 3. So we have negative 5/3, and on the other side, we have x is equal to 1. Now, if we substitute these values here, if we substitute 1, then of course, this is positive. Now, you may try substituting x equals 1 and x equals negative 5/3. The result here is positive. So therefore, it is defined. Take note, by definition of logarithm, if we have this, a and b must be positive. These two must be positive. C can any be number. It can be positive, negative, or 0. But a and b must be positive. So meaning, after solving, you may try to check whether your logarithm is defined or not. When we say logarithm, the a and b, or the base and this one, must be positive. So here, again, we have the same step. So convert this one to exponential form. So we have 3 raised to 1 equals 2x plus 1. So 3 raised to 1 is just 3. So you can transpose positive 1. So it will become negative 1. So we have 2. So dividing both sides by 2, we have x is equal to 1. Next, okay, the same thing. So x minus 1, this the quantity of this raised to 2 is equal to 4x minus 4. Then expand, this is equal to x squared minus 2x plus 1, or you may use the uh, FOIL method. This is just equal to x minus 1 times x minus 1. So we have x squared negative x plus 1. So we have x squared minus 2x plus 1. Okay, so FOIL method, so distribute and distribute. So that is why we have x squared minus 2x plus 1, and then just copy the other side. So we have this transpose. So you have x squared minus 6x plus 5 equals 0. So we have x minus 5 times x minus 1 as the factors. So therefore we have x equals 5 and x equals 1. Okay, now if x is equal to 1, take note that if x is equal to 1, the base will become 0, which is not positive. Take note, the base must be positive. 0 is not a positive number. So therefore, we will not allow x equals 1. So we will only accept x equals 5, because if you substitute 5 here, then this is positive, this is 20 minus 4 is 16. Then we have x minus 1, so 5 minus 1 is 4. So that is positive, positive. And further, you may recheck that if it is equal to 2. So as an example, sige na lang. Example. So log of 4 times 5 is 20. Minus 4, that is 16. And the base is 5 minus 1 is 4. Take note, this is equal to 16 is 4 squared. So base 4, by the property of logarithm, this is just equal to 2. So it's equal to 2. Therefore, x equals 5 is correct. Okay, now x equals 1 again is not a solution because the base will become 0 and it is not defined. Number 8, okay, we have this. So after this, we may apply the property. Number 3, these 2 will become an exponent of x squared. And then, of course, we also have log here. Okay, typo error. We also have log. So log 16. Now, by one-to-one property, now, in our previous video, of course, we have the one-to-one property. So this is also the part 2 of the video for some additional examples. So if we have this, so the same base, of course. So this is only applicable if they have the same base. If we have this, then of course, A is equal to C. So meaning in this case, both of them are base 10. The base is 10 because it is not written. So by convention, the base is 10. So therefore, it's equal to x squared is equal to 16. Okay, and then taking the square root, it is plus and minus 4. Again, by the definition of logarithm, this should be positive because we do not have any log of a negative number. So we will only accept positive 4. Number 9, so we have this. So on this side, on the left-hand side, we will apply the property 3. The coefficients will become exponent. So like this, so y cubed, and then we have 2 squared. Now on the other side, since this is plus, we can apply the property number 1. So we can multiply 8 and 4. Okay, take note, log 2 squared is 4. Okay, and of course, by the property of a multiplication, so this is plus, so we can multiply y cubed and 4, so we have 4y cubed. And then by one-to-one property, we can apply the one-to-one property for logarithm. 4y cubed is equal to 32. We can divide both sides by 4. 32 divided by 4 is 8. Taking the cube root, so y is equal to 2. Take note, 8 is equal to 2 cube. So if we take the cube root, that is, we take the cube root 1 over 3, we can cancel out 3. So we have now 2 raised to 1. So the answer is 2. Y is equal to 2. Number 10, so we have this. So by the property of addition or multiplication, this is equal to this, x times x minus 6 equals 4. And then now we can apply the from logarithm to exponential form. So this is 2 raised to 4 equals this. Okay, and distribute. So 2 raised to 4, by the way, is 16. So distribute x squared minus 6x, and then transpose 16, we have negative 16. And then the factors of this are x minus 8 and x plus 2. Okay, and then we have two values of x. X equals 8 and x equals negative 2. Now, if x is equal to negative 2, take note from here, if x is negative 2, it is not defined because again, we do not have any logarithm for a negative number here. Log of a negative number is undefined. So meaning all of these will become undefined, so therefore it is not allowed. We will only accept 8. Okay, if we have 8 here, so log of 8 base 2. Here we have 8 minus 6 is positive 2, so it's still defined. Log of 2 base 2. Number 11, okay, by 1-to-1 property, so we have this log base 2. So we have 4x plus 5 is equal to 6x minus 7, and then transpose 7 plus 5 or 5 plus 7 is 12, 6 minus 4 is 2, so divide both sides by 2, we have x equals 6. Number 12, we have this. So we can divide both sides by 4. Okay, so we have ln 2x is equal to 3. Now take note, ln is just the log base e. Okay, so every time we have this one, this is always equal to e cube raised to e raised to 3 is equal to 2x. Okay, so divide both sides by 2, we have this. Take note, e is a constant, and since we are not allowed to use a calculator, therefore we will have this as our answer, a cube over 2. 13, we have this, so I can transpose this ln so that it will become positive, and 1 transpose on the other side. So we have 2 minus 1 is equal to ln x minus 3. So again, this is e, the log of e, so this will become e raised to 1 is equal to x minus 3. So we always start from the base. The base here is e. So transpose, we have e raised to 1 is e, so plus 3. This is our x. 14, so this is minus. So I can transpose it on the other side. Or if you want, you may apply the division. Okay. By the way, you can have other solutions on these problems as long as you do not violate any rule on logarithm or in algebra. Then, of course, you will arrive with the same answer or answers. So, transpose, and then by 1-to-1 property, this is equal to this. And then transpose, we have x will become negative x, 9 will become negative 9. So we have now x squared minus 2x minus 8. So this is x minus 4 times x plus 4. So we have two values. X minus 4 is equal to 0 and x plus 2 equals 0. So x equals 4 and x equals negative 2. Okay. Now, although this is negative, if you substitute negative here, it is still defined. Okay, so this will become 7 because 9 minus 2 is 7. That's positive. So log of 7 base 13 is positive. Now here, negative 2 squared, this will become 4. Negative times negative 2, this will also become positive 2. So both of these are positive. So if you look at this is log of 7 base 13 minus, this is also log of 7 because we still have plus 1 base 13. So of course, this is equal to 0. So it is not always the case that if your x is negative, we will always disregard that answer. So all you need to do is recheck. Okay, check the answer if it's defined or not. Okay, 15. So the same thing, I will transpose that 1 to the other side. And then by 1-to-1 property, then dividing both sides by 16 and taking the square root. Okay, if we take the square root, we have this. Since 9 is 3 squared, 16 is 4 squared. Now take note that both are defined. Now take note our variable of concern here is x, not a. So not a. So x, if we square this one, either of these two, the plus or minus 3/4, the result is always positive. So this one is always positive. So it's always defined. 16, we have this. So again, you may try the division property of logarithm or transpose Okay, so since there is 1 here, so we may try. So as an example. So this is minus, so this is equal to log of x minus 5 over 9 base 8 equals 1. And then we can apply the exponential form. 8 raised to 1 equals this expression. So multiplying both sides by 9. Okay, multiply both sides by 9 so that we can cancel 9. So we have 9 times 8. That is 72. And then transpose. Negative 5 will become positive 5. So x equals 77. Number 17, we have this. So take note that 25 is equal to 5 squared. So we have this by the property of logarithm. So this is equal to 2. And then I can now transpose 1. So we have 2 minus 1, so equals 1. And then applying the exponential form, we have 5 raised to 1 equals 3x minus 1. So transpose, so we have 6 equals 3x, so dividing both sides by 3, the answer is 2. Again, you may use another method in finding the value of x. Okay, last example for equations. We have this. So take note, we cannot apply the logarithm for, the one-to-one property for logarithm because we have plus 3. So I can transpose this one to on the other side. And then we can, since this is minus, this is equal to this, division. And then apply the exponential form. So 2 cubed is equal to this. So that is. And then multiply both sides by 6 minus x. So that we can cancel x minus, 6 minus x. Okay, multiply both sides by 6 minus x. So cancel, cancel, and this also 6 minus x. So that's why we have this. So distribute, we have 48 minus 8x equals x plus 3. Then I can transpose 8x on the other side, so positive 8x. 3 to the other side, negative 3. You have 9x. So therefore, x is equal to 5. Okay, so again, we have lots of strategy in solving logarithmic equations. As long as you do not violate any rules in logarithm or in algebra or in exponential form, then you're good to go. Your answers will be the same with the other solutions. Okay, thank you for watching.